In this video, I will introduce you what is Nicole Prism. So Nicole Prism is used to make polarized light from an unpolarized light. I will explain you what is Nicole Prism. So these are two prisms joined. So one prism is having an angle of 68 degree here, 90 degree here, and 22 degree over here. Another prism, same thing, 22, 68 and 90, these are joined together. And these prisms are made with calcite crystal. So this is calcite crystal prism in this way, and this is another calcite crystal in this way. And these are glued together using Canada balsam. Okay, this is a special type of glue that is having a refractive index approximately equal to the value that of glass. Now here I am allowing an unpolarized light to pass through this prism. So at this point it will undergo refraction. You need to understand one thing, that refraction of different rays having different oscillations would be different. I'll repeat it. Now see, in an unpolarized light we have two types of oscillations generally. One is in this plane, okay, one is perpendicular to this, okay, perpendicular to this plane, and another one is this one. Or I can simply say with respect to my board as one oscillations in this plane, okay, up and down, and another oscillations perpendicular to this plane. So these oscillations are called as extraordinary ray, and these are called as ordinary ray. So initially extraordinary ray and ordinary ray are together because these are unpolarized light. But this extraordinary ray, the one which is having oscillations in this way and one which is having oscillations towards me and away from me, that is ordinary ray, these two will have different angle of refraction on passing through calcite crystal. So one would be refracted less and the ordinary ray would be refracted more. So refracted more means that would be deviated like this. So what has happened? As these two rays here, both of them are traveling together, but from here it got separated because one deviate with lesser angle and another deviate with more angle. Okay, so now this has deviated with more angle. Now at one point this, okay, again we got one medium to another medium. This is one medium, then I have a Canada balsam, right? Calcite crystal, Canada balsam, and calcite crystal again. So again there is movement from transfer from one medium to another medium. So what will happen? Refraction will happen. What will happen in the case of extraordinary ray? They will just refract and go in one direction. So from unpolarized light, extraordinary ray and ordinary ray got separated, and extraordinary ray that will meet Canada balsam and that will go with a refraction. Okay, that is collected here. But what will happen to ordinary ray? As this angle is more, this angle will become a certain value such a way that this won't undergo refraction. See, this we have learned previously. So when light travel from denser to rarer, okay, so if this angle, let's say this is the angle initially, what will happen? From to rarer, when it goes, it will move away from the normal. Now I am increasing the angle once again. So this is angle of incidence. Now this angle will become this, that will go along this direction. Now if I am increasing the angle more, then that would be refracted, reflected. That will come, that won't go refracted, that won't go for refraction, that would simply come back. This is total internal reflection. So that will happen in the case of ordinary ray. And our crystal is cut in such a way that this ordinary ray can always be collected at this side on total internal reflection. So what has happened? Extraordinary ray and ordinary ray got separated here, but extraordinary ray has gone in this direction after refraction, but this doesn't refracted. This at this interface, that totally internal reflection occurred here, and that has collected here. See, now this is a polarized light having an oscillation in this way. Okay, now this is extraordinary light ray that is having an oscillation in this way. So this is a polarized light, this is another polarized light. These two are having different oscillations, but these two are polarized. You can just keep an analyzer here in this way, that would allow the light to go. In this way, that won't allow the light to go. If I am keeping in this way, that would allow light to go. If I am keeping in this way, that would block it. So this is Nicole prism. Using Nicole prism, we can get ordinary light and extraordinary light, and that too, these two are independently polarized. Okay, thank you.